All right, so we have all of our basic formulas in mind for these. Again, they're all going to stem from that general rule we gave, that the outside times the whole is equal to the outside times the whole. So in the number one case, the 9 is outside, and the whole would be the total, x plus 9. In the other case, it's a tangent, which means all of it is outside. So we'd say 15 times 15, or 15 squared. So here we have 9x plus 81 equals 225, or that 9x will equal, let's see, what's that going to be? 144? So we get x to be 16. Okay? In the next example, we do have two secants. So we have the outside times the whole equals outside times the whole. The whole in this case being 5 plus 3 or 8. So we get 4 times x plus 4 equals 24. Or if you divide both sides by 4, that x plus 4 has to be 6. So x has to be 2. Okay? All right, moving on to number 3, very similar. Gotta make sure that focus is good. There we go. Much better. Oh, that's not a lot better. That's better. All right, so here, let's just zoom out some. Great. Outside is 4. Inside is x minus 3, but the whole would be 4 plus x plus 3, or minus 3, I'm sorry. So we've got 4 times x minus 3 plus 4 is going to be equal to the product 5 times x minus 6 plus 5. Or 4 times x plus 1 equals 5 times x minus 1. All right, zoom out a bit. Let's make sure we see where the whole again was x minus 3 plus 4. The whole here was x minus 6 plus 5. All right, so we have 4x plus 4 equals 5x minus 5. Or x equals 9. Right, if you add your 5 with your 4x. Okay, number 4, 6 squared equals 4 times x plus 4. Or 36 equals 4 times x plus 4, meaning x plus 4 has to be 9, where x is 5. Okay, further to a different rule, now we've got chords that intersect, and they are proportional. So I'm going to label this A and B, this C and D. And we're going to use that simple rule that AB is equal to CD. So AB in this case is going to be 36x. CD in this case is going to be 8 times 4x plus 2. Right, so I've got 36x equals 32x plus 16, or that 4x equals 16 and x must be 4. All right. Same exact concept in number 6. 4x equals 5 times 8 or 40. So x must be 10. Much easier one. I like that one. All right, number 7, a tangent and a secant. So the tangent does obey the outside times the whole rule. Here's the thing. The outside is the whole. So we have 6 times 6, or 6 squared, equals x times x plus 5. Or 36 equals x squared plus 5x. Uh-oh, we've got a quadratic. And the way to solve a quadratic is to set it equal to 0 by subtracting. So we'll get rid of that. We'll make that 0. And this will have a negative 36 over here. Which then factors x plus 9, x minus 4, giving us one single answer that makes sense, the positive answer. So x equals 4 for this one. We could say, hey, but doesn't x equal negative 9 make sense here? No, because x is a physical dimension that must be positive. All right, if we look at number 8, same rule, outside times the whole, 6x plus 8x, or 14x, equals outside times the whole. 7 plus 9 gives us 16. So, 8x times 14x, yikes, 112x squared equals, now 7 times 16, oh, that's nice, 112. So x is going to be plus or minus 1, but in the case of this problem, x has to be positive. So just the positive 1. Hopefully I did my math right there. All right, moving on to the back side. These are a little bit easier, so zoom out a bit. Make sure I can get all this on. There we go. And let's tilt some. Nice. Okay. So from here, zoom back. Yeah, there we go. So we're looking at different parts of a circle where x represents the radius. That is the distance from the center. The only information we're given here is that this little segment here is 4.3 and this segment is 10.6. But if this is a right triangle, this one is also a right triangle. This distance here, the hypotenuse, is equal to the x, the radius of the circle. So what we've got to do is a Pythagorean theorem. 4.3 squared plus 10.6 squared equals x squared, because this is the same as the x, right? So take a quick second, figure out what that is on your calculator. And hopefully you're able to do that on your calculator. And we get that x squared equals 130.85, or that x is roughly 11.4. All right. This next one, number 8, is not nearly as bad, or is it? It's exactly the same. You see, we have a right triangle here. We know this side and this side. We're looking for the hypotenuse, which is the same length as x. How do we know that's true? Because it's a radius. It's drawn from the center to the edge of the circle. So 4.4 squared plus 8.3 squared equals x squared. Or let's see if I can do that. So we're getting 9.4 for x. And again, that makes sense because that side has to be the longest for the entire triangle. All right, moving on to number 9. Right, another Pythagorean relationship. Since we have the right triangle here, right? So we've got x squared plus 8.4 squared equals 10.4 squared. Or moving our 8.4 squared over and solving for x, we get that x equals 6.1. Number 10. So what we know about this one, what do we know about this one? That this triangle, which is a right triangle, has a hypotenuse of 12.5, which is the radius. That means I can draw it over here. And what we're allowed to do now is use these two sides together to find our missing side, x. Again, using the Pythagorean theorem. X squared plus 10.8 squared equals 12.5 squared. Or x equals 6.3. Now that makes sense because the radius is 12.5. Whatever segment we get here, focus, there it goes. Whatever segment value we get there for x must of course be less than 12.5. All right, let's change colors. So moving on to number 11. We did a problem very similar to this in class. What we've got to do now is figure out how can I represent x. Well, let's take a look at, if we draw the rest of the diameter here, we know its value is also 16.7 because it tells us that radius. So we're going to find a new value here. Y squared plus 15 squared equals 16.7 squared. Right? So if we solve that, we're going to get that y equals 7.3, and x, you see, must be the continuation of this point to get to the edge, meaning x plus y is 16.7, and if we know the value of y at 7.3, then we can then conclude that the value of x must be the difference between 7.3 and 16.7. So, how much is that? 9.4. Okay, moving on. Make sure you focus on that. Yep, that worked. Great. All right, 12. Very similar situation here. We know this distance also to be 15.1. It's a radius, so 15.1 squared plus, equals 12.8 squared plus, we're going to introduce another letter here, y squared. So we'll solve for y. And we'll get that y equals 7.8. So of course you know that x plus y has to equal the entire radius, which was 15.1. And if y is 7.8 of that, then what is there left for x? X must of course be 7.3. All right, last two. So we talked about in class how a radius, when perpendicular to the chord, bisects the chord. So If I can get a little bit better focus here. Maybe if I zoom out some. Therefore, what is going on here? Well, we know the entire diameter is, of course, 30. Well, that means that this distance is 15. So how can we then use that to figure out what x is? So if we put all our knowledge together for this problem, we know that this length is also 15. And if this is bisected, then this is 14.1. So the Pythagorean theorem, 14.1 squared plus something. Let's put another letter there. How about a y? If I can get it to focus and you can see it, that would be a lot better, a little bit more beneficial. Yeah, there we go. Oh, maybe too close. All right, 14.1 squared plus y squared will be 15 squared. And so we're going to get that y equals the solution to that, which is, of course, 5.1. And if this distance is 5.1, then the x, of course, has to be the helper with the 5.1 to get to the 15. So 15 minus 5.1 equals x, which has got to be 9.9. 9.9, yeah. Okay, last one. So what have we learned from this one? We know the radius is 18.9. Anywhere else you can draw and identify a radius, you want to do that. And if we also know that this distance is 15.7 due to the chord bisection by the radius, the perpendicular radius, then we're going to do a similar scenario here with this triangle. Similar scenario, like I said. We're going to introduce another letter here. We know that this side is 15.7 and this is 18.9. So we have 18.9 squared equals y squared plus 15.7 squared. And from there, we'll solve for y. Let me just do that real quick. We're getting 10.5. So let's make sure we understand what that 10.5 means. That's this distance. And if the total distance is, of course, 18.9, we subtract those to get the remainder, the x. And in this case, that's going to be 8.4. Good luck. Focus. Yes, I'm talking to you. Yeah. Okay.